So, welcome everyone again to another episode of lecture series of archive of knowledge, of wealth, of resources made available and accessible to you by LearnCity as far as professional course in accountancy is involved. So, just implore, get a coffee, a glass of coffee, a cup of coffee, get some snacks, look for a comfortable chair, rest your back and enjoy the lecture. So, you are welcome to today's class. We'll be looking at the episode on the topic germane, important, inevitable as far as management and cost accounting is involved. Topic on linear programming. Linear programming. According to what I said the other time, linear programming is a topic that is important, that is germane, right from the lower levels, be it ATS levels, up to the advanced levels, be it performance management in ICANN, that's in Nigeria skills level, or in ACCA performance management, or APM advanced performance management in ACCA. So, it's a topic that is inevitable, that must always or of surety you are going to come across in your pursuit of professional certification or academic prospects in accountancy. Linear programming. I'm talking about linear programming is actually a technique that is built, that is developed, that is set in order to be able to provide a solution to a problem in accountancy or cost accounting that we call limiting factor problem. Actually, limiting factor is a topic on its own. But for the purpose of today's class, we did only be looking at linear programming as it solves limiting or scarce resources problem. So, what is linear programming? We will be taking this section by looking at the meaning and nature of linear programming, after which we are going to be looking at how do we formulate linear programming, and also what are the possible methods by which linear programming could be applied. So, what is the meaning and what's the nature of linear programming? Linear programming can be defined as a mathematical technique which is concerned with the allocation of limited resources to competing activities. I always told us in our previous classes, I always endeavor to avail my tutee or my students. Anytime you are defining costing or management accounting topic or any topic in accountancy, endeavor to note the technical words within the context of the definition. Words like mathematical technique, words like allocation of limited resources, words like competitive activities are germane technical words that must be fully understood while for successful application of linear programming techniques. Now, let's go again. What is linear programming? Linear programming can be defined as a mathematical technique which is concerned with the allocation of limited resources to competing activities. How limited resources can be shared, can be effectively distributed, can be optimally allocated among competing activities. This is what we refer to as linear programming. In other words, linear programming is a resource allocation tool. So we use linear programming as a tool to allocate scarce resources among competing activities. So this is the nature, this is the meaning, this is the definition of linear programming techniques. So, in other words, when we are talking about linear programming, it is mainly concerned with the optimization of objective function. Listen to the word, objective function. Now, for every operational activities embarked upon by a firm or an organization, there is always an objective, or probably what we could say as a goal to that activity or operational activity. So, the expression of this objective in a mathematical function is what we refer to as objective function. Now, as far as linear programming is concerned, objective function on operational activity could either be in two ways, either profit maximization or cost minimization. These are the two forms of objective functions in accountancy. Every firm will always seek to either maximize its profit or to minimize its cost. Either of these two are the objective of every operating firm. So when we express, when we depict, when we capture, when we delineate this objective function, this objective in a mathematical function, then we refer to it as an objective function. For example, Company XYZ Nigeria Limited produces product Y and product Z. For every 100 units of product Y produced and 150 units of product Z produced, XYZ intends to make a contribution not less than, intends to optimize its contribution. Then, representing this in an objective function approach will be C, which is contribution, is equals to 100x plus 150y. So, we look at what level of unit or output would give us the optimal contribution or profit to be maximized. This is expression of objective in a mathematical function. In other words, objective function. So, the nature of linear programming is such that it is concerned with the optimization of objective function. That is, maximization of profit or minimization of cost given some constraint, limiting factor, given some restrictions. For example, the variables or the parameters that will be used in achieving this objective, such as man hour, such as labor hour, such as quality of materials, the labor, the machine, the material, and other input components that will be used to produce the output in order to maximize the objective. These input components will always pose a constraint or restriction on our operational activity. So, in other words, linear programming is domesticated on two things: objective function and the constraint function. We have an objective to achieve. Unfortunately, there are constraints, there are restrictions that is not allowing us to achieve this objective. Then, linear programming steps in by showing us the optimal way, the maximum way, the highest way we could actually allocate our resources within this constraint, and we'll be achieving to the highest peak our objective function. This is the nature of linear programming. Finally, in today's class, before winding up or moving to another series, I would like us to look at what are the assumptions governing linear programming. What are the assumptions backing up the applications of linear programming? Number one, in linear programming, we assume linearity of the objective function and the constraint. In linear programming, linear assumption is preempted. In linear programming, we assume that the objective function is going to be expressed on a linear equation, while the constraint also is going to be domesticated on a linear equation. For example, C contribution equals to equality, linearity, equals to 100x plus 150y. Also, the constraint, let's assume material A is equal to or less than 100 units. So, everything about the formulation of the equations that makes up a linear programming are all linearity. So, in other words, this guarantees the additivity and the divisibility of the functions involved. We can easily add or easily divide, probably in the process of equation computation, or probably maybe elimination method, or any form of linear equation computation we are carrying out. This guarantees we could always successfully carry such out at every time in which linear programming is in application. So, it assumes linearity. Number two, linear programming assumes non-negativity of the decision variable. That is, negative quantities of an activity are not possible. Actually, in the formation of linear programming equations, after the formation of the objective function, the formation of the constraint function, which is going to be based on the decision variables or the components of the input element, the last form of formulation that we make is the non-negativity formulation. That is, we say x, y, z, if there are three decision variable, is not equal to 0. So, in other words, linear programming assumes non-negativity. We get to know more of this and acquainted and familiar with this in a subsequent series of video on calculation and workings on linear programming. I believe you've actually enjoyed and gained something on this video. I actually implore and join us to continue with us in our next series, where we'll be looking at different methods by which linear programming can be applied, and also how linear programming techniques can be formulated and the steps involved. Thank you and God bless.